There are two types of potential energy. Gravitational potential energy, which is stored when you are in the top of a hill, and string potential energy, which is stored when you stretch a spring or an elastic band.
The potential energy is the energy that is stored in an object.
There are two types of mechanical energy. The first one is potential energy, and the second one is kinetic. When an object is going down a hill, there has to be always a balance. So if at the start you start with all of your potential energy, and when you go down you start losing it and convert it into movement.
Then we have the kinetic energy, that is all the energy that is based on movement. For example, when we have a car and it is down the hill, all the energy that is produced thanks to the movement is a kinetic energy. The formula of kinetic energy is 1/2 multiplied by mass and multiplied by velocity to the square.
The formula of the potential energy is about mass, height, and the gravitational acceleration of the object.
Finally, the formula for the mechanical energy is the addition between the potential and the kinetic energy.
The law of the conservation of energy states that energy cannot be created nor destroyed. It can only transform. Okay, well, how we made this car is that first we had to cut the wood according to the measurements that we calculated to do to everything to be proportional. And well, after that we had to join all the wood pieces with these little metal pieces for it not to separate and the structure to collapse. Then a very important part is the directional. What we did is that we use a big nail, and well, we went through the wood with it and we adjusted it, but not too tight for it to be able to move. So you can see how the wheels work is that they are attached to a metal piece, metal axis, and well, they're adjusted with another little part of metal for them not to go out. And well, they have a little balero in order for the wheels to be able to go faster and not produce many friction.
Okay, so now that we have already seen how the car went, we're gonna proceed with the calculations. Well, first of all, in order to calculate all the other things that we have to know, the first essential part is to calculate the height. How did we do that? Well, we measured the descent from a site and we measured 4 meters and an elevation angle of 30 degrees. So we used the sine of 30, which is 0.5, and calculated that the initial height of the vehicle was 2 meters. Now, the second thing is the mass. The car had a mass of 42 kilograms, and the pilot, which was our classmate Ruben, had a mass of 64 kilograms. So the total mass was 106 kilograms. With the given values, we can calculate the initial potential energy. We calculate the potential energy by multiplying the mass times the gravity times the initial height of the car, and this will give us a total potential energy of 2079.72 joules, which would be the same as the mechanical energy since we don't have any kinetic energy at the beginning. Following the law of the conservation of energy, we can say that the initial mechanical energy is the same as the final mechanical energy, which would tell us that the kinetic energy at the end of the slope is 2079.72 joules, since it will have a total height of 0 meters. If we want to know what is the final velocity of the car, we can simply isolate the velocity from the formula of the kinetic energy, getting the following equation. We can simply substitute the formula and get that the final speed for the car, using significant figures, is 6 meters per second.
And that's it.